All right, you guys, so we're going to go ahead and do the application of absolute value equations, example number 4. Now, it needs to be said that this particular equation is based on body mass index. There are people in the world who do not believe that's a good measurement of a person's health, so just keep that in mind. That's my disclaimer. But if you do subscribe to the idea of body mass index, then this particular equation will supposedly find a man's, quote, normal weight range. This is for men. The ladies in the room, if you're wondering, I'm sure you are, I can tell the ladies in the room are wondering this. Mr. Sudoku, where is our equation? The equation for women is on the homework that was uploaded. So you will do an example involving a woman. But each person, if you want to apply this to yourself, men, plug your height into that and do the math as we're about to enjoy, and get your, quote, normal weight range. And then the ladies in the room, you can use the one that's on homework if you would like to do the same. All right, so just make sure you use the appropriate equation. And so this is for men, and we have a man named Bill, and we're told that Bill, his height, his value of h, is 6 foot 2 inches. Now, we've talked a lot about the fact that frequently you have to adjust. This formula requires the height to be completely in inches. So we've done this before. There are 12 inches in a foot, right? So those 6 feet would be 72 inches, and then the additional 2, so Bill is 74 inches tall. How's that? All right? So we'll go up here, and for Bill, we'll put 74 in for his height. So I'm going to put 74 in parentheses where the variable h stood. And you'll notice that the remaining variable now is w. We're going to find his, quote, normal weight range. All right, now in the interest of space here, I need to go ahead and square that number. And so 74 times 74, I'm sure you remember from grade school, 74 times 74 is 5,476. You learned that in grade school, right? Okay, so we've got what now? An absolute value equation with the variable w. So at this point in time, we go back and go, all right, I got a recipe for that. Let's get the absolute value by itself. And you would notice that this expression is on one side by itself, so we don't need to do anything in terms of isolate. Split, all right, so I'll spare you the number line this time. But just like the previous examples, if this expression that's inside here has an absolute value of 2.85, doesn't that mean that that entire expression, 703.07w over 5476, minus 2355, that whole thing could equal negative 2.85, right? That's a number that has an absolute value of 2.85. I'm a little nervous about running out of space. Oh well, we'll make this work. All right. Couldn't that expression also equal positive 2.85? So, we carry down that whole thing in its entirety. We don't make any modifications to the expression inside there, and we set it equal to positive 2.85. So notice again, we've got the positive 2.85 and the negative, and we set that expression equal to both of those. Then we'll solve the two that are left, all right? These are both linear. W is to the first power. I would be an advocate of, since that variable w is in one place, how about we use inverse operations? Let's see, parentheses, exponents, multiply, divide, add, subtract. So how about we add the 2355 over? All right, oh boy, I'm gonna need to grab a calculator here. I should be able to do the math in my head, but it's embarrassing to have to rely upon a calculator. This is the point where I usually ask one of you in the room, what does that equal? So, what does that equal? I got 20.7. Yeah, I did too. Thank you. That's right. All right. And then we're back to the order of operations. That's multiply, that's divide. Let's go ahead and get rid of that division by multiplying both sides by 5,476. That'll clear the fraction here. You got to remember this is over 1, right? Cancels. So we're left with 703.07w equals, and then that 20.7 times 5476 is 113353.2. I invite you to hit pause if you ever need to, if I get going too quickly. But this is mechanical stuff here now. And then, of course, wouldn't we get rid of that multiplier with division at this point, whereby we divide by the 703.07. And you guys are racing me, hopefully, trying to get the answer faster than Mr. Sombrero, all right? Anyway, this would lead to a value of W of approximately, I'm going to call it 161, all right? I was a little sloppy on the rounding there, to be honest with you, but I'm not going to make a big deal out of that. All right, so to the nearest pound, that was 161. All right, same thing over here. I get it. There was something back here that I probably should have done a little differently on the rounding, but let's get close here. All right, same thing. Let's use inverse operations in order to isolate the W. We'll get rid of the subtraction first. It's the very same series of steps. It's just a different number over there. So I'm hopeful that these steps are reviewed. This is assignment 8 going on right here when we had linear equations, because again, the variable W is to the first power. Okay, add that over. Wouldn't the next appropriate step be to get rid of the division that the fraction represents with multiplication of 5476 over 1, right? Okay, on both sides. Okay, so over here it cancels and leaves just that numerator. See you later, numerator. After a while, percentile. Awesome, thank you for that response. All right, so anyway, 144,566.4, and then we'll get rid of that multiplier with division. And that'll leave W, and W ends up on this one being approximately, and so divide by 703.07 is 205.6. I really should round that down to 205 to make sure the guy's between the two. But anyway, I'll round 206. I'm not going to quibble over a pound. Maybe I should. All right, so a little bit of sloppiness there. Now, as far as a word problem, see, the question was that they wanted us to find the guy's appropriate normal, so to speak, weight range. So to write this up, I would just simply say that he should weigh anywhere from 161 pounds to 206 pounds. In all honesty, I should have rounded inward in both cases. The better answer is 162 pounds to 205 pounds. But again, you know, I'm just going to be gracious with you on things like this. I know I'm supposed to be a picky math guy, but given the circumstances, that would be a 10-minute discussion we don't have time for. So that wraps up absolute value equations, and that again would be assignment number 13 that you will find uploaded. Thank you.